RBS Busy Research Academy welcomes you in the lecture number 10, and in this lecture number 10 we are understanding how to perform EFA exploratory factor analysis in Jamovi. Dear friends, there are several applications of the factor analysis. Factor analysis can help you in reducing the data from your sample size. Another one, factor analysis can also provide you results for subsequent analysis. Subsequent analysis, that means the same results you can apply for multiple for computing multiple regression, or for applying the CFA confirmatory factor analysis, or you can also use the same one for applying the statistical equation modeling on the results which you are getting from the EFA. So now let's start to know how we can perform in the Jamovi. But before this one, my name is Dr. Rainbal Sumro and I belong to Shabdat University, Pakistan. So here, this is the interface of the Jamovi. First of all, we have required to attach the data set with the Jamovi. So we have data set SAQ. SAQ means Statistical Anxiety Questionnaire, where there are the four our constructs. The first one is a fear of computer, second one is a fear of statistics, third one is a fear of mathematics, and the fourth one is the peer evaluation. By applying the factor analysis, we are trying to grab either these four factors, or we are able to get or not, or what type of the item they are, where they are loading. So now here the SAQ like the questionnaire with this, and first up we have to go through the variable. So now total there are the like the 23 items are there, and these are the levels of every item. So now analyze. So how go into the factor and find out the exploratory factor analysis, and then select all these one except the demographic variable like age, gender, qualification, all these one. You have to move all these items from this window to variable window. As you will move, then you will find some of the like the results which are these selected by default. By default this is selected, then that's why you are getting this result. So initially without any rotation, so without any extraction, like extraction rotation, we have received 6 factors. Okay, so now actually let me say what we assume that in our data there are the 4 factors. For example, what is the model which you are applying in your research, there are the 4 factors. So here are the 6 factors. So actually we need 4 factors. Okay, so now one more thing, that before applying the exploratory factors, making sure that you have a sufficient sample size or not. Like here this shows that this is a reference, and it shows that 200 sample size. If it is, that's a fair. At least this is a good sample size where you can apply the factor analysis on this data. Otherwise, if you have the 10 observation per variable, even you can also apply the factor analysis. But at least the minimum sample size should be 200. Then you can apply. If this is a 300, good. If it's a 500, that's very good. And higher the sample size, that you will get the more stabilized results from your EFA. Now, so first off, we have to choose the method. Which method you are going to choose? Extraction. In the extraction, there are the 3 methods. Minimum residual is like a least square method in the regression. Another is a maximum likelihood, and another is a principal excess. So here we are selecting maximum likelihood. So now what you should select, your theory will suggest you which type of the extraction method you should use. But here I'm using the maximum likelihood. Rotation. Whatever rotation method you can use, there are the 5 rotation methods. All these are the Varimax, Quantimax, Promax, Oblique, and Simple Max. And this is the none. So now which type of the rotation method we should choose, let's depend. Again, your literature will guide you which type of the you can use. However, you are looking here, these are the 2 rotation methods. This is an oblique rotation method. You are looking that the data is rotated in the one direction. So now this arrow is following this arrow, then again both arrows are following in the same direction. And this is the this is orthogonal, sorry, and this is the oblique. In the oblique, all the data point, they are crossing each other. If this one is going clockwise, then this is going to the anti-clockwise. So now here somewhat there is an intersection of the data is there. That means the both data set, they are going into the different direction. So this is called the rotation That means that after selecting the exploratory technique, the software rotates the data according to your own choice. So there are the 5 choices are there, but here we are selecting the from very mix, because mostly people are using this very mix. Otherwise, whatever your literature suggests you can select. So here number of the factors, how to extract number of the factors. So 3 approaches are there. First one is the based on parallel analysis. So now what do you mean by the parallel analysis? Here you're looking. This is a wonderful paper which is written by the name of this one is using Horn's parallel analysis method in exploratory factor analysis for determining the number of the factors. How to determine the number of factors in abstract? It is they are writing that in this study the number of the factors obtained from the parallel analysis. That means whatever the factors you are getting from the parallel analysis and whatever factors you are getting from the actual data, you have to compare both one. A method used to determine the number of the factors in exploratory factor analysis. That means that in the exploratory factor analysis, whatever the factors you have obtained and the whatever factors you obtained through the parallel analysis was compared to the factors obtained from the eigenvalue and the script. Okay, so now parallel analysis is based on the random data generation. That means the software randomly generates the data, which is called which is the parallel to the actual data set. Actual data set means a data set which you have attached with the software, and another data set which has been developed by the software itself by using the Monte Carlo simulation technique to determine the number of the factors. So that means that 2 data sets are there. One is from the like the Monte Carlo simulation technique. Through this one data set has been developed by the software, and another is the data set which you have attached with each other. So now they are going to compare these 2 data sets here. So now if you are working on this one, then you are looking at the 6 factors are there, but we are interested in the 4 factors. Otherwise, you can select the based on eigenvalue. So eigenvalue again, so when you have the 0 eigenvalue, then you have the 9 factors. But in the literature science, at least there should be the 1 eigenvalue. So if you are selecting 1 eigenvalue, then you have the only 1 factor. So now Kaiser criterion. Now there's a Kaiser criterion. According to Kaiser criterion, you have to go for the eigenvalue 1. But another researcher statistician is the Jamovi. He says that the Kaiser criterion is a too strict. Instead of using this one, we should use they means Jolie first. Now, if we are following 0.7, then again we have the 2 factors. But again, these 2 factors are not serving our purpose. So the next thing is that we have to provide a fixed number. Then not 1, not 2, but we need 4. So that's why instead of the 1, you should write down here 4. If you select the 4, then the 4 factors will be extracted. Now you're looking, we have the 4 factors. Okay. Now assumptions are very important. First one is the Bartlett's test of sparsity. This test basically check the normality of your data. If data is normal or non-normal, and then if this test is significant, that means we should be happy that our data is normal. And then another is a KMO. KMO basically checks the adequacy of your sample. That means that if your sample is adequate or not. And then how to understand that one. Next one is assumption check. In the assumption check, there are the 2 assumptions. First one is the Bartlett's test of specificity. This test basically check the normality of your data. Either data is a normal or non-normal. It would be good or it will be in your own interest if you go and apply the box plot before applying the exploratory technique. If the box plot suggests you that your data is normal, then definitely your data will be normal. Otherwise, Bartlett's test of specificity is also available. If it is significant, that there should not be any problem of the collinearity or non-normality in your data. The another one is a KMO. KMO test is basically a check that either the sample on which you are applying a multiple regression, either that is significant or not significant in this regard. Okay, and then a few myths I want to tell you of the KMO. So now this is the KMO, Kaiser, Meyer, Olken, and Bartlett's test. So here KMO varies from the 1 to 0. Now here, if the value of the KMO is zero point 0.9, there's a marvelous, and zero point 0.8 meritorious, zero point 0.7 middle, and the zero point 0.6 mediocre. So up to zero point 0.6 you can go, but normally people prefer to have zero point 0.7 and higher than 1. If it is less than zero point 0.6, then you should not apply the EFA on this result, on this data, if the KMO value is zero point 0.6 or less than. The solution of this problem is that you should collect the more data and add the data, then again apply the KMO, and then if it reached the 0.7 at least, then you should apply the KM, like the effective analysis on your data. Okay, and then you are looking sort. So now you're looking that this data is not sorted. So if you want to sort them, then you should select the sort in ascending order. It will always sort your data in ascending order. And then you're looking here that those values who are less than no, high loadings means that if those loadings whose value is less than zero point 0.3, those will be hidden. So here there is no any hidden value, because all the values up to after 20%, 23, they are more than 0.3. So that's why all the values of all the questions items are visible to you. Now it is better to increase its 0.3 to 0.4. Normally I select 0.5. Less than 0.5, those should not be visible to us. So now, because the GIGO, garbage in, garbage out. So if you are putting garbage over here, then for further analysis, when you apply CFP or distribution modeling, at that time you will require to delete all these items by the software. So otherwise, you will not be able to meet the basic criteria of applying that technique. So it is better to apply 5, but I'm applying the 4 because I believe in the like the. So it's good to apply the 5. So now first I'm going to apply 5. So now after applying the 5, wonderful, we have the very clear pattern is there. So now this item is this factor. There is only one item in this factor. There are 3 items, 4 items, and 5 items. So if I go back like the from 0.5 to 0.4, then we have the more factors. Now we are looking here, then we have the sum of the one. Now some of the items have been loaded on each item. So this is because of the very mix. But if we select rotation method quality mix, what happened? The majority of the factor items they have loaded on a single factor. So now if this is so, now it is not a clear pattern. So now that's why I always try to choose a varimax, because the beauty of the varimax is that it loads the item almost equally on every factor. So now same you're looking here. Okay. Now furthermore, you can also go for additional output factor summary, factor correlation, model fit, initial eigen values, and script plot. Okay. So now you are looking some of the issues which are here. And then you should exclude it from the analysis. Again, you will get another. Oh, again, 18 has also a same problem. So in this way, basically, you can have a clear pattern. As I told you, it's an exploratory factor analysis. So now that you have to apply those two through which you can get a clean and clear pattern. Okay. Another issue is still this there. That's up with the question number 7. So now now it's a clear. So that means out of the 23 items, 4 items have been excluded from the analysis, and 19 items have been retained. So now it is our clear pattern. So now almost a 6 item they have loaded on the factor 1, 3 item on the factor 2, 3 item factor 3, and 3 item on the factor 4. So all they have been loaded. So now this type of the clear pattern is required by applying the factor analysis, because these items you will there is a carry forward for applying the other techniques like the static equation modeling, the multiple regression, and CFA confirmatory factor analysis. And the remaining these items you will not consider to carry forward. Only these items which are mentioned here, these you will consider to carry forward. Okay, and then uniqueness. So this is a uniqueness. Now, what is this uniqueness? So here you're looking here, this is the same uniqueness here. So now the column uniqueness refers to the amount of the variance in that item unexplained by the factor. So now basically two things are there. One is the explained and the other is the unexplained. So this is the unexplained by the factor, the unexplained value by the factor, and community. Initially, we consider that the community of every item is 1. So now you're looking here, community of every item is 1. So if we deduct 0.36 from this community, it will become 0.63. So 0.36 is a unexplained and the 0.63 is a explained variance. So that is a concept of the like the uniqueness. So in our case, the unexplained variance is a 0.55 and explained variance is a 0.45 over here. And then if we go down, these are factor statistic. So these are the eigenvalue of all the factors. And then this factor analysis, inter-factor correlation. As we applied the Verimax, so we should not be worried about all these things. And when you apply Oblique, then because Oblique requires the intercorrelation among the items. So now we are applying Verimax, so don't worry about this one. Okay, and then model fit. So these are some values of the model fit. So now model fit, we can be careful about this one when we apply CFA, conformity factor analysis. So in this one, we should not be much worried about this one. But even so, if we go through this one, Ramsey root mean standard error. So now this is commonly applicable indices. Normally we use it. So if its value is less than 0.06, that means it's a close fit, and then it is a 0.08, then it is a commonly accepted. So now it is a close fit, but we cannot commonly accept it. And then these upper bound and lower bound at the 90% confusion interval TLI, Tucker's Lewis index. So here 0.90 is its value, and if its value is if its value is 0.9 to 0.95, it's good. So now it's within the range. And more thing is that about the p value. The p value is less than the 0.001. It means it is good. Okay. So now it's a Bartlett stress sensitivity. Again, it is significant. So that's why we should be happy that there is no any problem of the multi-collinearity with your data. So this is the KMO, like the Meyer sample adequacy. So overall is our 0.9. And it is also providing the item-wise Meyer sample adequacy, that either this data is adequate for applying the factor analysis or not. So now this data is quite good. Okay, and then in last, the eigen values are here of anyone according to eigen value. According to this, based on eigen value, there is only one factor. As we have demanded 4 factors, so that's why we will not consider this one. And this is the screen plot. This also suggests that there is only one factor against this eigenvalue. So now, if we go with the eigenvalue, then we can think, okay, there's a one factor, but we have demanded the 4 factors, so that's why we will not consider this one. So, okay, so in this one, we have completed our factor analysis in the Jamovi. If you have any question, you can write me. My email address also you're looking here. And whatever the files I have shown in this one, I have put the link of all those ones behind this video. You can click that link and you can download. So at the end of, thank you very much for watching this video. I hope this video has clarified so many your concept regarding the EFA in Jamovi. So at the last, I request you to subscribe my channel, to comment on this video and share this video with the rest of the people. Thank you very much.